Hi, this is John Whitaker for the Mathematical Analysis 2 class, and this is our 13th lecture. And last time we ended with the theorem that said that if you have two Riemann-Stieltjes integral functions, and you add them together, you get a Riemann-Stieltjes integral function. And the integral of the sum is equal to the sum of the integrals. And also that if you have a constant times a Riemann-Stieltjes integral function, that is going to be integrable, and the integral of the constant times f is equal to the constant times the integral of f. And so we want to continue with several more facts related with having Riemann-Stieltjes integral function. And let us start off with the following fact. It says if f sub 1 and f sub 2 are Riemann-Stieltjes integral functions with respect to alpha on a to b, with f sub 1 of x always being less than f sub 2 of x, then the integral from a to b of f sub 1 d alpha is going to be less than or equal to the integral from a to b of f sub 2 d alpha. This is not something I'm going to prove, but instead I'm going to say that the proof is left to the students, so this will be part of the homework assignment we'll have. Okay. The next fact I will prove, and here's what it says. It says if f is Riemann-Stieltjes integral on a to b, and a is less than c is less than b, so c is what we're concentrating on. C is some number in the closed interval that isn't equal to a or b. Then f is Riemann-Stieltjes integral on a to c, and f is Riemann-Stieltjes integral with respect to alpha on c to b. Not only that, but also that the integral from a to c of f d alpha plus the integral from c to b of f d alpha, that's going to be equal to the integral from a to b of f d alpha. This is something I'm going to prove. Okay. Proof, we're going to let f be Riemann-Stieltjes integral on a to b, and a be less than c be less than b. Okay. Let epsilon be greater than 0 be given. Again, we're going to use that fact that we had to show that something is Riemann-Stieltjes integral, in that we're going to show that there's a partition such that the upper sum minus the lower sum is going to be less than epsilon. Okay, so since f is Riemann-Stieltjes integral on a to b, there exists a partition, that we call it strict B, of a to b, such that, and for notation's sake, I'll say the upper sum, and I'm going to say with a to b, of of the partition f alpha minus, I'll say the lower sum, where we're looking at the integral from a to b, of this partition of f and alpha, is going to be less than epsilon. Okay, now what we're going to do is take a refinement, if need be. So I'm going to let P star be equal to P union C. So if C was not in our partition, then we're going to throw it in as a refinement. And then, because of what we're proving about refinements in terms of upper and lower sums, what we're going to have is this upper sum may be, or with this refinement, F alpha minus this lower sum of A to B with this refinement of alpha. That's going to be less than epsilon. That's what we have. Okay. It is going to be less than epsilon. It's true. But actually, I wanted to look at something else. So, sorry. Then, let's look at this difference. What is this difference? This difference is the sum as I run from 1 to n of those supremums minus those infimums times the delta alpha sub i's. Okay, and for notation, what we'll say is suppose in our partition that the x sub j entry in the partition is equal to C. So this is going to equal to the sum as I runs from 1 to, let's say, j of the m sub I minus the little m sub i's delta alpha sub i's plus the sum as I runs from j plus 1 to n of, again, this big m sub I minus the little m sub I times the delta alpha sub I. Okay. That's true. That's definitely true. It's not what I should concentrate on. But that's what we have. Okay? Now, okay. So if we look at this first sum, so this sum is I run from 1 to j of the m sub I minus the little m sub I delta alpha sub I. So let's go on that. That's going to be less than or equal to this upper sum A to B of this P star partition F with alpha minus this lower partition A to B for P star F alpha. Okay. And then that, of course, is less than epsilon. That's what we have. So P star, if we look at it from A to C, so restricted, this is the notation I'm going to use, restricted. And what that's equal to is the x of 0, x sub 1, up to x sub j, okay? And it's a subset of P star. And this is going to be partitioned of A to C. Okay? And if you look at this upper sum from A to C, with this partition, P star from A to C, F alpha, minus this lower sum over A to C, with this partition, A to C star, F alpha. So if you look at this, okay, that's going to be less than the upper sum over A to B of P star F alpha minus the lower sum from A to B, P star F alpha, which of course is less than that sum. Okay. So this is exactly this guy, and it's less than what we've written here, less than or equal to, and so that's how we're getting less than epsilon. And so what that says is that F is Riemann-Stieltjes integral on the closed interval from A to C. Similarly, if we look at the sum as I runs from J plus 1 up to N of M sub I minus the little m sub I times the delta alpha sub i's, that's going to be less than or equal to the sum as I run from 1 to N of the big M sub i's minus the little m sub i's, delta alpha sub i's, and that's equal to the upper sum over A to B, the P star F alpha minus the lower sums over A to B, the P star F alpha, which is less than epsilon. And this part here was nothing more than, if you will, using similar notation. So the upper sum over B to C of this P star from B to C of F alpha minus the lower sum over B to C with this partition B to C F alpha, that's going to be less than epsilon. Where this is the partition P star of B to C, what that's equal to is the same partition P star on A to B, but we're just looking at the parts of it that include, I'm sorry, this should say C to B. Let's make that change. Okay, so this partition over to C to B is the part of the partition from A to B where we're looking from C onward. Okay? So what this tells us is that F is Riemann-Stieltjes integral on C to B. Now, an upper sum from A to C of a partition F alpha plus the upper sum from B to C partition from F to alpha. This is equal to the upper sum from A to B partition F to alpha, where we're generating this partition from these smaller partitions here. Here A to C, here A to C. Okay, where C is being included. Okay, and similarly, the lower sum, A to C, plus this lower sum. Again, this should be C to B. I made a mistake. C to B. We'll equal this lower sum here. From A to B. And this is true for the partition including C. Okay. And so, the enthemum of these guys, of the union from A, of the upper sum from A to C, with these partitions. Plus the enthemum of these upper sums from C to B. Now that'll be less than or equal to the enthemum of these types of partitions, or these types of upper sums. These types of upper sums. And so, what we have is that A to C of F d alpha plus the integral from C to B of F d alpha will be less than or equal to the integral from A to B of F d alpha. That's what we have. Okay, similar to that. Also, we have the suit of these lower sums from A to C. P F alpha plus the suit of lower sums from C to D, P F alpha, is going to be greater than or equal to the soup of the lower sums from A to B of P F alpha. Okay. And so this is the integral from A to C of F D alpha plus the integral from A to C of from C to B of F D alpha. It's going to be greater than or equal to the sum of, here it's F D alphas. And so, on one side we've got the sum is less than the integral over A to B. On the other hand, the sum is greater than, and so that means that they have to be equal to each other. Okay, so that's what we have. And so that concludes this proof. Okay, next theorem. It says if F is Riemann-Stieltjes integral on respect to alpha on A to B, and if absolute value of f of x is less than or equal to m on A to B, then we have that the absolute value of the integral A to B of f d alpha will be less than or equal to m times alpha b minus alpha of a. Okay, let's look at the proof. Let's let f be an element of Riemann-Stieltjes integral functions with respect to alpha on A to B. We'll let the f of x inside absolute value be less than or equal to m on A to B. Okay. Now, here's the first thing to notice. No, the integral from A to B of f d alpha, well, that's less than or equal to the upper sum for any partition we have. Remember what that's equal to. That's the sum of the B given sub i's, delta alpha sub i's. Okay. But that's going to be less than or equal to the absolute value of, or m, I should say big M, as I runs from 1 to n, of the delta alpha sub i's. And if you take out that m, it's a constant. So that's m times the sum as I run from 1 to n, delta alpha sub I. Okay. And so that sum of the delta alpha sub i's, as we've seen before, lots of those terms will cancel out. And so what we're left with is this is equal to m times alpha of b minus alpha of a. So that gives us that the integral from A to B of f d alpha is less than or equal to m times alpha of A minus alpha of B. Similarly, also, we have that the lower sum of the partition, F alpha, will be less than or equal to the integral from A to B of F D alpha, because this guy is equal to the sup of all these types. And we notice that this lower sum is equal to the sum over I running from 1 to n of the little n sub i's, delta alpha sub I. And that's going to be greater than or equal to the sum of the minus m's as I run from 1 to n delta alpha sub i's. And that's equal to minus m delta, sum of the delta alpha sub i's, if I run from 1 to n. And again, that's minus m times the quantity alpha of B minus alpha of A. Okay, that's wonderful. Now, what that means is that this integral from A to B, writing it this way, minus m times alpha of B minus alpha of A is going to be less than, okay, so this guy's bigger, integral from A to B of F D alpha, and we've shown on just a second ago, in the previous part of the board, that this is less than or equal to m times alpha of B minus alpha of A. And so when you have something sandwiched between a positive number and that negative of that same number, then that says that the absolute value of that middle quantity is going to be less than or equal to m times alpha of B minus alpha of A. And that's what we wanted to put. Here's a next theorem. It says if f is Riemann integral with respect to some alpha sub 1, and f is Riemann integral, Riemann Stieltjes integral, I should say, with respect to some alpha sub 2, then f is Riemann Stieltjes integral with respect to alpha sub 1 plus alpha sub 2. And not only that, the integral from A to B of f d alpha sub 1 plus alpha sub 2 is equal to the integral from A to B of f of d alpha sub 1 plus the integral from a to b of f of d alpha sub 2. Let's look at the proof of that. So let f be an element of Riemann integral functions, and Riemann integral functions with Riemann-Stieltjes integral functions with respect to alpha 1, and f be an element of Riemann-Stieltjes integral functions with respect to alpha 2. So I have to say. Okay, then note for any partition of A to B, then the upper sum with respect to this partition F and alpha sub 1 plus alpha sub 2 is equal to the sum as I runs from 1 to, let's say, n, of the big M sub I times delta of alpha sub 1 plus alpha sub 2, which is equal to the sum as I runs from 1 to n of big M sub I, and then what is this going to be? This is going to be, well, alpha sub 1 plus alpha sub 2 acting on x sub I minus alpha sub 1 plus alpha sub 2 acting on x sub I minus 1. Okay. Now that's equal to, well, that's going to be the sum as I runs from 1 to n of m sub I, and rearranging these terms. Here I'm going to take the alpha sub 1 of x sub I minus the alpha sub 1 of x sub I minus 1. So that's really, if you will, the delta alpha sub I, or alpha sub 1, I, plus the sum, this big M, I runs from 1 to n, of delta alpha sub 2, I. I'll write it that way. And that's going to be equal to, of course, this is the upper sum with respect to the partition, alpha sub 1, plus, here, this is the upper sum partition of alpha sub 2. So we've shown that the upper sum with respect to any partition without an alpha 1 plus alpha sub 2 is equal to the upper sum with alpha sub 1 plus the upper sum with alpha sub 2. Okay, similarly, same type of computation. We have the lower sum with any partition of alpha sub 1 plus alpha sub 2 will be equal to the lower sum any partition of alpha sub 1 plus lower sum any partition alpha of alpha sub 2. So we'll let f sum be greater than 0 be given. And since f is an element of the Riemann-Stieltjes integral functions with respect to alpha sub 1, and f Riemann-Stieltjes integral with respect to alpha sub 2, then excuse me, there exists these partitions P1 and P2 of A to B, such that
the upper sum, P1, F. Here, I'll just write it down in one term. I'll say F P sub J, F alpha sub J minus the lower sum is less than, let's say, epsilon over 2. Now, our setup for our work is wonderful, except this statement here, it's really two statements, and they have two different partitions. What we'd like to do is, we've got work set up for just a single partition. So what we're going to do is take the refinement to get one type of partition here. So let script P equal to P sub 1 union P sub 2. Then what we have is this statement that the upper sum of P star F and an alpha sub J minus the lower sum of P star F alpha sub J. That's going to be less than epsilon over 2. Now that's really two statements in one. Alpha 1, alpha 1, alpha 2, alpha 2. Okay. So we take those two statements, add them together. Just take those two inequalities, add them together. What we have is the union, the upper sum of P star F alpha 1 plus the upper sum with P star F alpha 2 minus the lower sum of P star alpha sub 1 minus the lower sum P star F alpha sub 2. But that's going to be less than epsilon. But this is the upper sum P star F alpha 1 plus alpha 2 minus, this is the lower sum P star F alpha 1 plus alpha 2, and that's going to be less than epsilon. And so what that tells us is that F is Riemann-Stieltjes integrable with respect to alpha sub 1 plus alpha sub 2. That's not quite all proved. Okay. Okay, so since this lower sum is equal to the addition of these lower sums, then what we have is that the soup of this guy is going to be less than or equal to the soup of those two, of each one of those two guys added together. So that's going to be F, the integral from A to B of F, D alpha to 1 plus alpha to 2 is going to be less than or equal to this interval from A to B of F D alpha 1 plus the interval from A to B of F D alpha 2. Similarly, since we have this upper sum, is equal to this upper sum plus this other upper sum. Then, okay, we'll take the theme of this guy. So this A to B of F D alpha 1 plus alpha 2 is going to be greater than or equal to these guys, the theme of each one of these guys, which is going to be the integral from A to B of F D alpha 1 plus the integral from A to B of F D alpha 2. So from these two inequalities, we have that integral from A to B of F D alpha sub 1 plus alpha sub 2 is going to be equal to the sum of these. And that completes that proof. Okay, here's a theorem. It says if F is Riemann-Stieltjes interval with respect to A and C is greater than 0, then F is Riemann-Stieltjes interval with respect to C times alpha, and the interval from A to B of F D alpha is going to be, of F D times C alpha, F of D of C alpha, should say, is going to be equal to C times the interval from A to B of F of D alpha. So here's the proof. We let F be Riemann-Stieltjes interval with respect to alpha and C be greater than 0. We're going to let epsilon be greater than 0. Let script P be a partition of A to B. Now, the upper sums with respect to C alpha, that's going to be equal to the sum of this M sub I, so I runs from 1 to n, of delta C sub alpha I, and that's going to be equal to sum as I runs from 1 to n of M sub I, and then this is nothing more than C alpha of this will be x sub I minus C alpha x sub I minus 1, and that's going to be equal to, you can pull out that C times the sum as I runs from 1 to n of the M sub i's And then here, the rest of it, with the C's taken out, we just have the alpha x sub I minus alpha x sub I minus 1, and that's the delta alpha sub i's. And that's just equal to C times the upper sum of P, F, with alpha. Similarly, same type of computation. We have the lower sum, P of F with C alpha, is going to be equal to C times the lower sum, P, F, and just alpha. Now these statements are true for any partition, but since we're assuming that F is Riemann-Stieltjes integral with respect to alpha, then there exists this, we'll say, P sub 1 partition, such that, it's a partition of A to B, such that the upper sum of this particular partition minus the lower sum of this particular partition is going to be less than any positive number. Positive number we're going to pick is epsilon over C. So given this positive number, we'll pick the P sub 1. That is, by that famous theorem that we use for Riemann-Stieltjes integrals. Okay, so, you know, if I multiply everything by C, we'll get the following statement. And so, replacing these items by what they're equal to in terms of C alpha, we have the upper sum, P sub 1, F, C alpha, minus the lower sum, P, F, C alpha. It's going to be less than epsilon. And that, of course, tells us that F is Riemann-Stieltjes integral with respect to C alpha. It's great. Not quite finished with the theorem. Okay, so since C times the upper sum, P sub 1, F alpha, minus C times the lower sum, P sub 1, F alpha, it's less than epsilon. Then, this integral of F d C alpha will be less than or equal to this upper sum, P sub 1, F C alpha, which we know is equal to exactly this quantity. Which is going to be less than epsilon plus C times the lower sum alpha. I'm just moving this over here by adding it. Okay? Which is less than epsilon plus, here we take the sup of these. And so it's going to be, ends up being C times the sup is the soup of over all partitions of C times L over the partitions F alpha. And then here, this is going to be equal to epsilon plus, this C can be brought out, it can be positive. And C times the soup over all partitions of the set of the lower sums with alpha. And that's equal to epsilon plus C times integral from A to B of F d alpha. So what we have is that this integral F d of C sub alpha is going to be less than or equal to, because epsilon is arbitrary, C times A to B of F d alpha. Okay. Also, since C times the upper sum, P sub 1 F alpha minus C times the lower sum, P sub 1 F alpha is less than epsilon. What we have is that the integral from A to B of F d of C alpha, okay, that's going to be greater than or equal to the lower sum of P sub 1 F alpha. Remember, you take the soup over all these lower sums, that's how you get this guy. This should say C alpha. Okay. But that's equal to C times the lower sum P sub 1 F alpha. And if you look at this inequality here, add this to both sides, subtract epsilon. What you got is that that's bigger than or equal to, or just bigger than, C U, the upper sum, P sub 1 F alpha, minus epsilon. Minus epsilon is what we have. Okay. So that's going to be greater than the infinimum of the C of the upper sums. And this is over all partitions. Alpha minus epsilon. And then this C can be brought out front. This is equal to C times the infinimum over all partitions of the upper sum P of alpha, and then minus epsilon. And then this is equal to C of integral from A to B of F d alpha minus epsilon. So this work shows that this integral from A to B of F d C alpha is going to be greater than, well, since epsilon is arbitrary, it's going to be greater than or equal to C times the integral from A to B of F d alpha. So we combine the two inequalities we have to get the result. Let me write up that conclusionary statement just a second. That says that the integral from A to B of F d C alpha is equal to C times the integral from A to B of that theorem. And that's what we need to show.
Okay, that concludes lecture 13. Thank you very much.